Right, so it gets us. We've been looking into this wild idea that maybe it's not just energy or entropy that's the real driving force in the universe, but information density instead.
Oh, yeah.
Like, seriously, we might be talking about a total paradigm shift here.
It really is a fascinating concept.
Yeah, we've got like a whole stack of papers, research summaries, even some informal discussions.
Right.
And today we're going to try to like unpack it all.
Sounds good.
We'll try to connect it to things we see every day.
Okay.
And then go from there to explore, how it might actually like rewrite the laws of physics.
It's pretty mind-blowing when you really start to think about it.
Okay, so let's start with something everybody knows. Like, why does heat rise?
Right.
I mean, we all know it does, but have you ever really thought about why?
Well, it all comes down to density.
Okay.
When you add heat, you're basically making the molecules move faster and spread out so the substance becomes less dense. And just like a less dense object is going to float on water, the less dense air rises above the denser, cooler air. That's right.
Like basic physics.
Yeah.
But it kind of sets the stage for this bigger question, like, what if information is similar, but instead of seeking lower density, it actually wants to go to a higher density state?
Well, that's like a total mind bender.
It is.
So how does that apply to the big picture then?
Right.
Like, how could information trying to get to a higher density state, how could that be connected to, the fundamental forces of the universe?
That's where things get really interesting.
Mm-hmm.
One source I was looking at uses this really powerful analogy to try and describe how information density could relate to the four fundamental forces. The strong force, the weak force, electromagnetism, and gravity.
Okay.
They say, imagine the strong and weak forces acting like rate limiters.
Rate limiters, sure.
And electromagnetism is like the boss that manages all the information flow.
Boss, huh?
And gravity is like the mouth of the universe,
Yeah.
Constantly consuming information.
Whoa. Okay, I'm intrigued, but I need a little help unpacking this analogy.
Yeah. Like, let's start with the strong force. What's it limiting?
So the strong force is what holds the nucleus of an atom together.
Right.
It binds those tiny quarks to form protons and neutrons.
Yeah, okay.
It's incredibly powerful. But in this framework, it's like a super strict gatekeeper.
Right.
It's limiting how much information can change or spread within those really tightly bound structures.
So it's maintaining like a certain level of information density within the atom's nucleus.
Exactly.
Okay, what about the weak force then?
Okay, so the weak force is a bit more subtle. It governs things like radioactive decay, where particles actually transform into other particles.
Right.
So it allows for controlled changes in information content.
Okay.
Which enables evolution and change within the system.
I see.
Think of it like a carefully guarded valve.
Okay.
Permitting specific types of information to flow through while blocking others.
So strong force is the gatekeeper. Weak force is the valve.
That's a good way to put it.
And that brings us to electromagnetism, the boss of information flow.
The big boss.
What's that all about?
Well, think about it. Electromagnetism is responsible for light electricity, and so many interactions we experience every single day.
Aye.
It's constantly transmitting and organizing information throughout the entire universe.
Wow.
It's the force that enables communication energy flow, the movement of particles on a grand scale.
So it's like electromagnetism is one like orchestrating the flow of information.
Exactly.
Wow, that's powerful.
It really is.
Okay, so we've talked about three of the fundamental forces.
Right.
But I'm still a little unclear on how gravity is like the mouth of the universe.
Okay.
How does that fit into this whole information density picture?
So gravity is the force that pulls everything together, right?
Right.
It shapes the large-scale structure of the universe.
Uh-huh.
It draws matter and energy into increasingly dense states like stars, galaxies, and eventually black holes.
Okay.
In this framework, black holes might actually be the ultimate information repositories, pulling in and concentrating information along with everything else.
So gravity is constantly feeding the universe more and more information.
That's the idea.
Fascinating.
And it suggests that the universe is constantly learning and becoming more complex.
Wow.
But here's where it gets even more interesting.
Okay.
This whole idea of information density might actually change how we think about the very laws of physics themselves.
Really?
Yeah, for example, one of the cornerstones of thermodynamics is the concept of entropy.
Right, entropy.
Which is often described as a measure of disorder.
Yeah, I remember that from physics class.
Right, entropy always seems to be increasing things tend toward disorder.
Yeah, exactly.
But what if we look at it through this lens of information density instead?
Okay.
So instead of thinking about increasing entropy as disorder, could we view it as information spreading out, becoming less localized? And could that decrease in density actually be what drives processes in the universe?
So instead of just randomness and chaos, there's a purpose, a drive towards a more evenly distributed information state.
Exactly. It's a completely different way of looking at it.
Oh.
And it might even have implications for one of the most mind-boggling aspects of physics, quantum mechanics.
Oh, boy.
Yeah, things are about to get really wild.
Bring it on.
It's full of these phenomena that just seem to, totally defy our everyday understanding of reality.
Right.
But what if we look at these phenomena, through the lens of information density?
Okay. I'm ready to have my mind blown wide open.
All right, well, think about superposition.
Okay.
Where a particle can exist in multiple states, simultaneously.
Yeah.
What if this is just representing a state of low information density, where the information hasn't quite settled into a more defined, higher density state yet?
So instead of a particle being in multiple places at once, it's more like the information about its location just hasn't solidified. Like the universe is still processing the data.
It's like the universe is running this super complex computation, and those superposition states are just intermediate steps in the process, waiting for that final, more information-dense result to emerge.
Okay, that makes sense. But what about entanglement then?
Right.
Two particles linked, no matter how far apart they are.
Yeah.
That's always seemed like pure magic to me.
It really does defy our classical intuition.
Yeah.
But imagine if entanglement is actually information seeking the most efficient, densest connection possible. Like a cosmic shortcut that just bypasses the limitations of space and time as we understand them.
So information is finding the most direct path regardless of how we perceive distance.
Exactly. It's like a whole different set of rules.
Fascinating. Okay, and what about quantum tunneling then?
All right.
A particle passing through a barrier that it shouldn't be able to.
Right.
That one's always baffled me.
It's like the universe is optimizing for information flow, finding the most efficient path, even if it seems impossible from our limited perspective.
So the universe is basically saying, I know a shortcut.
Yeah, basically.
This is incredible.
Yeah.
So we're talking about rewriting the rules of reality as we know them.
It's a pretty radical concept.
If we can link information density to quantum mechanics and all the fundamental forces, does that mean we could control these forces by manipulating information?
That's the million-dollar question.
Right.
A lot of researchers in this field are really grappling with that idea.
Yeah.
Like, if we can figure out the language of this information exchange, the codes that govern these interactions, we might be able to tap into some incredible new possibilities.
So we're talking about, manipulating gravity, harnessing the power of quantum entanglement, maybe even creating new forms of energy.
It's all speculation at this point, but the implications are huge.
It's like we're on the verge of a technological revolution unlike anything we've ever seen.
It's definitely exciting.
But before we get too far ahead of ourselves,
Right.
What kind of experimental evidence would we need to gather to prove that information density is actually driving these fundamental forces?
That's the key. We need to move beyond just theory and analogy and get into the realm of testable, repeatable experiments.
So how do we do that?
Well, one promising avenue is exploring the link between gravity and information compression.
Information compression. Okay, can you explain that?
So the idea is if gravity is truly a manifestation of information density, then the way we compress data should actually be affected by the strength of the gravitational field.
Really?
Yeah, imagine conducting experiments where we compress a complex data set in two different gravitational environments.
Okay.
One with high gravity, one with low gravity.
So we'd be creating a controlled gravitational experiment.
Exactly.
And seeing if the compressed file sizes are different between the two environments.
Right. Even a tiny difference in compression efficiency could suggest that gravity is influencing information density.
Interesting.
Making the data more compressible in a stronger gravitational field.
Okay. That's a pretty elegant experiment.
Yeah.
But what about quantum mechanics then?
Right.
How do we test the connection between information density and those mind-boggling quantum phenomena?
Well, one idea is manipulating quantum entanglement.
Okay.
Imagine creating a pair of entangled particles and then intentionally leaking information about one particle's state and seeing if it affects the other particle instantly, regardless of the distance between them.
So we're messing with the entanglement.
Kind of.
To see if information is the key to maintaining that connection.
Exactly. It's a bold move, but it might just give us the evidence we need.
It highlights the need for some really creative, out-of-the-box thinking.
Definitely.
When it comes to testing these radical new ideas.
It's not going to be easy.
But the potential rewards are huge.
Oh, yeah.
If we can prove that information density is the driving force behind quantum mechanics and gravity, it would completely rewrite the textbooks.
It would change everything.
It feels like we're standing on the edge of a scientific revolution.
It really does.
But amidst all this talk of rewriting the laws of physics, I can't help but wonder, what does this mean for us?
Right.
What does this information-centric view of the universe tell us about our place in the grand scheme of things?
It's a really profound question, one that's puzzled like philosophers and scientists for centuries.
Right.
But this idea of information density, it really does offer a fresh perspective.
Okay.
It suggests that maybe we aren't just these passive bystanders in a, predetermined universe.
Yeah.
Instead, we might actually be active participants in this constantly evolving cosmic dance of information.
So instead of a clockwork universe where everything's already set in motion, it's more like an ever-changing information network.
Yeah.
Where we each contribute to the flow.
Precisely. We're constantly taking in information, processing it, generating new information through our thoughts, actions, our interactions.
So it's like we're all these nodes in a vast interconnected web of information.
Yeah.
Constantly exchanging data and shaping the fabric of reality.
It's a pretty wild thought.
It is. It's both empowering and a bit daunting. It suggests that our choices and actions, they have a real impact.
They do.
Not just on our own lives, but on the universe as a whole.
It really brings up some really interesting ethical questions, too.
Yeah, like what?
Well, if we're all contributing to this cosmic information flow, what responsibility do we have to make sure that our contributions are, positive, constructive, aligned with the well-being of the whole universe?
Like we're all authors contributing to the grand narrative of reality.
Exactly.
And we need to be mindful of the stories that we're telling.
We do, but it's not just about individual responsibility either. It's about collective action as well.
Okay.
If we can really understand how information shapes reality, we can start working together to actually create a better future.
Right.
One that's, more sustainable, more harmonious.
So we need to shift from a mindset of competition to one of cooperation.
Yeah.
Recognizing that we're all interconnected.
Right.
And our own individual well-being is totally linked to the well-being of everything else.
I think that's a really important point.
This has been an incredible deep dive.
It really has.
And I feel like we've only just scratched the surface of this idea.
Me too. There's so much more to explore,
Yeah.
So many questions left to answer.
But one thing is clear. This idea of information density.
Yeah.
It's a really powerful lens for viewing the universe.
Absolutely.
It challenges our assumptions, expands our understanding, and opens up all these possibilities.
And it reminds us that we're not just observers.
Right.
We're active participants in the evolution of the cosmos.
So to all of our listeners out there, keep questioning, keep exploring, and keep imagining.
The universe is full of wonder, and information might just be the key to unlocking it all.
That's a great note to end on. Thanks for joining us on this deep dive.
It was my pleasure.
We'll see you next time for another exploration of the frontiers of knowledge.